Hello, everyone. Welcome once again to our channel, Making Life Easier. Once again, welcome to our series on basic mechanics. Kindly subscribe, like, share, and leave your comments and suggestions at the comment section. Today we are looking at moment of a force about a point. Example 1. Quickly, let's look at our question and how to solve it. Determine the moment of the force about O using A, scalar approach, B, vector approach. This is our question. We are asked to determine the moment about O using both scalar approach and vector approach. Let's see how we are going to solve this problem. Good. So we have been asked to determine the moment about O of the force acting at W using both scalar and vector approach. Take note that anytime you want to find the moment of a force about a point, moment of a force about a point, and we have 2D objects, and we have 2D objects. You can use both the scalar approach. You can use both the scalar approach, and then you can also use the vector approach. You can also use the vector approach. And each of them will give you the same answer or a similar answer. So let us look at how to solve using both the scalar approach. So first of all, we are going to look at the scalar approach. And then we also look at the vector approach. So in this question, if you are asked to solve using the scalar approach, the first thing you need to do, look at our force. Our force, this force here, we cannot say that the force is in the X or the force is in the Y. You can see that our force is neither in the X-axis nor in the Y-axis. And we are told that the force makes an angle of 65 degrees with the horizontal axis. Anytime you have a force like that, what you need to do is to resolve the force into components, So here we can complete the diagram like this. You can complete the diagram like this, and you can see that if we resolve into components, this one will be pointing up like this, and then the horizontal one will also be pointing this direction. Don't forget that our unit vectors are in this form. Anytime we move to the right on the X, we say that it's positive. When we move in this direction, it's negative. On the Y, up is positive, down is negative. So take note, when you are finding the moments using the scalar approach, the direction of the force is important. So here you can see that our force in the X will be moving this direction. So this will give us F of X. And what we are moving up there will give us our Y component of the force, which is going to be F of Y. So now, with reference to this angle here, with reference to this angle here. So we complete to form a rectangle like this. So if this is f of y, then this side will also be f of y. And if this is f of x, then this side will also be f of x. So with reference to our angle which is here, if you want to get f of y, you can see that f of y is opposite our angle. F of y is opposite our angle. So we can say that our f of y, because it is opposite our angles, we were told that opposite over hypotenuse is always sine. So because our y side is facing our angle, our f of y is going to be f sine theta, will be f sine theta. And then we are told that our force is 250 kilonewtons. And then our theta is 65, so sine 65. So from here we can get our f of y, and our f of y is going to be 226.6 kilonewtons. What about our s component? Our x is this side, our x is this side. So here you can see that our s component is adjacent to the angle. We can clearly see that our s component is adjacent to the angle. As you can see from here, these are s component, these are x, and this is the angle. So our s component, f of x, will be equal to f cos theta. And from here, we can see that our s is 250 cos 65. And from there, our answer is going to be 105.7 newtons. Good. So once we have been able to establish that, then we have been able to resolve our force into components, the s component and then the y component. Now our distances are in millimeters, so we need to change from millimeter to meter. And we know that 1,000 millimeter is equal to 1 meter. So it means that when we change this 520 to meter, we are going to get 0.52 meter. And when we change this 320 to meter, we are also going to get 0.32 meter. Good. But don't forget that the formula for finding moment of a force about a point is using the scalar approach. The formula is the distance times f. And here, this distance is the perpendicular distance. Take note of that. This distance is the perpendicular distance. It's the perpendicular distance. So from here, we can say that when we take each of the forces we have resolved, this is our f of y, this is our f of x. So from here, when we take our f of x, this is our f of x. And from the principle of transmissibility, we will extend the force up to this point. We extend the force up to this point here. You can see that the perpendicular distance from the force to where we are taking the moment is O. From the force to where we are taking our moment is O. So if the force is applied somewhere here, using the principle of transmissibility, then the perpendicular distance is going to be from this point up to this point up to that point for our f of x. So if this is f of x, then it means that our moment is going to be the distance, the perpendicular distance here for f of x is going to be this distance, and we are told that it's 0.32 meter. So we are going to get 0.32 times our force, which is 105.7. Now let's check whether it will be positive or negative. If the force is applied here, and this is the perpendicular distance, we see that this force will tend to rotate the object in this direction. The force will tend to rotate the object in this direction. And from our conversion, this direction is clockwise. Anytime you are moving in the clockwise direction, our moment is going to be negative. So we are taking a convention that anytime you are moving in the anti-clockwise is positive. So here, the force will tend to rotate the object in the clockwise direction. So we are saying that this is going to be negative. Good. Then let's come to our y component. This is our y component. So in the same way, if we try to extend our y up to this point, we try to extend our y, then f of y is going to act this direction. And you can see that from, if this is f of y, the perpendicular distance from where this is applied to where we are taking our moment with this distance here, and then we are told that 0.52. So it means that our f of y, perpendicular distance for f of y will be the distance from this point up to that point. And we are going to get that one to be 0.52 times 0.52 times our f of y, which we know as 226.6. Now let's check whether it will be clockwise or anti-clockwise. If I have a force here, and this is a perpendicular distance, here, then this force is going to tend to rotate the object in this direction. Which in this case is anti-clockwise. So it means that our y component is going to give us a positive moment. And from here, we are almost done. We just need to do that simple computation, and we are there. So from here, we are going to get our answers as negative 33.8 plus 117.8. And from here, we have our final answer as 84 kilonewtons, 84.0 kilonewtons. That is the scalar approach. Now let's look at how to use the vector approach on the same question. Let's look at how to solve the problem using the vector approach. Good. You realize that when we're looking at the scalar approach, we're not considering the direction of the distances. We're not considering the direction of the distances. But when we are dealing with the vector approach, take note, when we are dealing with the vector approach, the direction of the force is very important. So the important points when we are dealing with the vector approach is the direction of the force, and then the direction of the distance. The direction of the distance is also very important. So if that is the case, then now what we need to do is to find what we call the position vector. The position vector, we know that the moment using the vector approach is going to be R cross F. This is the formula when you are using the vector approach. It's going to be R cross F. So from here, we need to determine this R here. This R here is what we call the position vector. We call it the position vector because it indicates the position where the force is applied from where we are taking our moment. It indicates the position of where the force is applied to where we are taking the moment. So anytime you want to get the R, take note of this. It's always the distance from, you will start from where you are taking your moment. You will start from where you are taking your moment to where the force is applied, not where the force is applied to where we are taking our moment, but rather it's where we are taking our moment from to where the force has been applied. So in this case, we are taking our moment at O. So it means that we want to get to W, where the force is applied, and then we are starting from point O, where we are taking our moment. Take note of that. We are saying that we'll be moving from where we are taking our moment O to where the force has been applied, which is W. So we have IW/O. And that will be, it means that we are moving from O to W. And here it means you move this direction, look at our X. And don't forget that we said that our conversion is this. Anytime you are moving on the right, it's positive, left is negative, up is positive, down is negative. So look at our direction. If we want to move from where we are taking our moment O to where the force is applied, you can see that we are moving this distance on the X. And you can see our direction there is in line with our unit vector. So it means our direction on X is going to be positive. So we are going to get positive 0.52 I. Then from this point, you can see that if you want to get to W, we need to move up. On Y, we need to move up. And because you are moving up, look at our conversion. Anytime you are moving up, it's also positive. So our distance on the Y is also going to be plus 0.32. And once you have been able to do that, it means that J, don't forget this one is J, and the horizontal one is I on the X-axis. Now we are done finding our position vector. What we are left with is also to find our force in the vector form. Our force in the vector form. So our force in the vector form will be the S component of the force and the Y component of the force. I have already established the fact that because the angle, if you complete to form a rectangle, we said that because the angle be facing the Y side is going to be sine, and the X side, because the angle is adjacent, is going to be cos. So our F in the vector form will be equal to our scalar force, which is 2F. For the S component, we are going to get F cos theta I, and then on the Y, we are going to get F sine theta J. And from here, we can just put in our values. We know that F is 250 kilonewtons cos theta, which is 65 I, plus 250 sine 65 G. And from here, we can get our force in the vector form, which will be equal to 105.7 I plus 226.6 G. And once we have been able to do this, what we are left with, we have our F in the vector form, we have R, our position vector also in the vector form. So now all that we need to do is to find the cross product. Moment is always equal to R W/O cross our force in the vector form. And from here, we can just put in the values. This is 0.52 I plus 0.32 J cross the force, which is 105.7 I plus 226.6 J. Good. So from here, the easiest way to solve, because it's a cross product, is to use the matrix method. So you can just write I, J, K, and you put in. So here I is 0.52, and then J is 0.32. K, we don't have any component, so it will be 0. Then for the force, our I component is 105.7 I.7. Don't add the I because you have already indicated up there. Don't add the I. So here we are going to get 105.7, and the Y component is 226.6. And in the same way, we don't have any component for K, so that will be 0. So once you have done this, we know that when we want to determine the determinant, this is plus, minus, plus. So from here, we can get our components for I, our components for J, and our components for K. So quickly, let's look at how to do that. If you want to get the I component, the J component, and the Z component, and the Z component, this is what you are going to do. We said that if you want to get the I component of the moment, if you want to get the I component of the moment, you cross all the I values there, and you'll be left with a 2 by 2 matrix. Then you find the determinant. So it's going to be this times this minus this times that. That is how to find the determinant. So for S component, we are going to get this times that minus this times that. So which will give us 0.3 times 0 minus 0 times 226.6. That will be the I component. Don't forget that for the J component, we have minus up here. We have minus on top there. So minus. Now we want to get the J component. So we said that you take away everything which is in the J side. You cross that side. And you'll be left with a 2 by 2 matrix of the I and the K. So you multiply this 0.52 by the 0 which is here, and then minus this times that. So you are going to get 0.52 times 0 minus 0 times 105.7, and this will give us the J component. Then lastly, if you want to get the K component, you also put away all the K elements there, and then you find the determinant of the remaining matrix. So this will be this times this minus this times that. So we are going to get 0.52 times 226.6 minus 0.105.7 times 0.32. And from here, we can easily get our value from the computation. So from here, our answer is going to, this will go to 0, this will go to 0, and our answer will only be left with this part, which will give us 84.0 newtons. So from here, you can see that our scalar approach kilonewtons. So from here, you can see that our vector approach is giving us 80 kilonewtons, and the scalar approach is 24 kilonewtons, and our scalar approach is also giving us 84 kilonewtons. That is pretty much simple, isn't it? Yes. So if you have any question or anything you didn't understand, you can kindly let us know at the comment section. We'll be happy to assist you with that. We'll be happy to assist you with that. Once again, thank you for watching. Kindly subscribe to our channel. Hit the notification bell as well. And then you like and you comment also. See you again in our next video. Bye-bye.